Okay, we are on part 3 of the problem solving and data analysis section of the text. We have to get through a section of statistics and then a section of probability, and then we're done with this. What we're going to start with is statistics, or not start with, this is on page 10 of this section, and we're going to start with statistics. Okay, which I think you guys have seen this before. This is probably a review. We're going to do mean, median mode, mid-range, range, and standard deviation. So you guys have probably seen all of this, maybe not standard deviation, but all of those terms will be on the exam. Then we're also going to go into the normal distribution, which again, you may not have seen that, but it will be on the exam. You will be tested over that. Okay, so we're going to start with the definition. It says a measure of central tendency is a value that represents average or typical of a data set and generally located toward the center of the distribution. There are 4 common ways to determine such measures: mean, median mode, mid-range. So it's better to use one of those 4 terms instead of using the word average. Okay, so this is saying if you're using the word average or a typical number for a data set, we know that you're thinking of a measure of central tendency, but which one? Mean, median mode, or mid-range? Okay, so we're going to look at all 4 of these, what each of these mean. Then I'm going to do an example where the numbers are very different, so you need to be very specific and when you're picking the measure of central tendency. Okay, so probably the most common measure of central tendency is the mean. Definition of the mean, it says the mean of a set of data is found by adding the data values and dividing the total by the number of data values. Okay, we denote the mean by x bar, and how we find that is we sum up all of the x's, or we sum up all of the data, and divide by n, okay, which is your number of data values. Okay, so example, what is the mean of 27, 52, 15, 68, and 25? Okay, so the mean, which is x bar, is summation of all of the x's divided by the number of data values. Okay, so we're going to add up all of these. 27 plus 52 plus 15 plus 68 plus 25, and then we're dividing by the number of data values we have, which is 1, 2, 3, 4, 5. Okay, so I'm going to use a calculator to add those up. Okay, and I got 187 divided by 5, which is 37.4. Okay, so the center of this data is about 37.4. Okay, so that is a center of the data, or the mean. Okay, next we're going to look at median. So the median of a data set is the middle value when the values are arranged in order of increasing magnitude. The median is often denoted by x tilde. To find the median, we're going to arrange the values in order, so we're going to go from smallest to largest. If the number of values is odd, okay, so for example here it was odd because it was 5, the median is the middle number in the list. If the number of values is even, the median is the mean of the 2 middle numbers in the list. Okay, so we'll do one example of each of those. So it says find the median for these data values. I'm going to go ahead and write these out in increasing order. So 15 is the smallest, then it looks like 25, then it looks like 27, 52, and 68. Okay, how many do we have here? 1, 2, 3, 4, 5. Okay, so that's odd. Alright, so we have put them in order. Okay, going back up here, we've done number 1. Okay, we're on number 2 now if the number of values is odd, which it is. Okay, the median is the middle number in the list. So I just go through and I start marking off. So first, last, second, second to last. The middle number is 27. So our median, x tilde, is 27. Okay, on to page 11. It says find the median for these data values. Okay, so first step is to put it in order. So 45 looks like it's the smallest. Looks like 59 is next. I'm going to go ahead and mark these off. 64, 77, 83, and 86. Okay, let's go ahead and count in here. So we have 1, 2, 3, 4, 5, 6. Okay, so going back to how to find the median. Median. There we go. We have arranged the values in order. We can't do number 2 because the number of values is even, so we need to go on to number 3. If the number of values is even, the median is the mean of the 2 middle numbers in the list. Okay, so we need to find the 2 middle numbers here. So mark off the first and the last, the second to last. So we're looking at these two. So we're finding the mean of these 2 numbers. So the median would be the mean of these 2 numbers, which would be add them up, divide by 2, since there's only 2 numbers here. Okay, so 64 plus 77, get out my calculator, 64 plus 77 is 141 median, or the middle
value. So again, this is another center of data. I want to go back to page 10 quickly. We found here the mean of this data set, 27, 52, 15, 68, and 25, was 37.4. Okay, the median of the same data set, 27, 52, 15, 68, and 25, is 27. Okay, those numbers are way different. Okay, but they still represent centers of data. Okay, one is the mean, one is the median. They're almost 10 off. Okay, but they still are important. Each one of those are. Okay, next is the mode. Okay, it says the mode of a data set is the value that occurs with the greatest frequency. So how I remember this is the mode is the number that occurs the most. So most and mode go together, so you have MO, MO. Okay, number 1, it says find the mode of this data set. So we're looking for the number that occurs the most. So we have 6, 7, 3, 4, 6, 4, 5, 4, 3, 2. I think I said 4 the most. Yes, so we have 4 here would be the mode. Okay, number 2, find the mode of this data set, which this actually is easier because we have it in order. So it looks like we have a mode of 4 and a mode of 5. Okay, so we can have 2 modes here. We have 4 and 5. Okay. When 2 data values occur with the greatest frequency, which what happened here, we say the data set is bimodal. So this data set above was actually bimodal. When more than 2 values occur with the greatest frequency, the data set is multimodal. Okay, so if we had maybe a 666 next, that would be multimodal. And then when no data value is repeated, we say there is no mode. Okay, so for example, at the top of page 11, when we found the median, here we would just say there was no mode if we were trying to find the mode. Okay, none of the numbers repeated. Okay, and then our last other measures of center, this is the bottom of page 11. We have one more, it's called the mid-range. The mid-range of a data set is the value midway between the maximum data value and the minimum data value. Okay, so the mid-range is the maximum plus the minimum divided by 2. Okay, highlight this plus. For some reason, I always see students subtracting. I think it's because when we do a range, we subtract. When we do the mid-range, we actually add. Okay, so mid-range, you add maximum plus minimum divided by 2. All right, so on to page 12. We're going to find the mid-range of 64, 86, 59, 83, 45, and 77. So we've actually already found the median for this. So now we're going to find the mid-range. I'm just going to write out the definition first. The mid-range is the maximum plus the minimum divided by 2. The maximum value is 86. The minimum value is 45, and then we divide by 2. Go ahead and add that together, divide by 2. 86 plus 45 divided by 2. I got 65.5. Okay, so for this data set, we found the mid-range is 65.5. The median, so this is back on page 11, was 70.5. Again, different. They're about 5 off. It is 5 off. Okay, but they're still both important. Okay, before we go on to measures of spread, I want to just look at maybe just a different data set here. Let's say we have that some city takes a random sample of 5 people. They want to find the average salary that the city makes. Okay, so let's say that out of the 5 people, one person makes $45,000 a year. Oops. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117, 118, 119, 120
Another person makes $45,000 a year. Another person makes 50. Another person makes, we'll do 51. Erase that. And then the fifth person, let's say, makes 120,000. Okay, so they want to find the average or a typical salary for this city. Okay, if we were to do the mean here, so X bar. Okay, so 45,000 plus 45,000 plus 50,000 plus 51,000 plus 120,000. You got about 62,200. So I just quickly did that. So remember, to find the mean, you add them up, you would divide by 5 here. Okay, if you were to do the mode, let's go ahead and write out the mode, because we can easily see that. It's 45,000. If we were to do the median, it would be 50,000. And then the mid-range, okay, so for this median, I went ahead and put, they were already in order. The middle value is 50,000, so I could see that. Mid-range would be 120,000 plus 45,000 divided by 2 is 82,500. Okay, so these numbers are very, very different. I would say the ones that I would use would be the mode or the median. Okay, this 62,200 is pretty high. That's way higher than 4 of these. Okay, the mid-range is even higher, so it's way higher than 4 of these. The mode and the median look pretty good. Okay, so you can see that these numbers are all very different. They're still measures of center. Okay, I would say 2 are better numbers to use. Okay, for the most part, we use the mean. Okay, but in this particular case, the mean isn't a great number to use. Okay, so moving on to page 12, we're going to do measures of spread. Okay, definition, it says measures of spread are used to describe the spread of data items in a data set. Okay, that means that we're measuring how spread out a data set is. Okay, the simplest one is range. Okay, definition, the range of a data set of data values is the difference between the maximum data value and the minimum data value. Okay, so the range is just the maximum minus the minimum. Again, you're going to need to know this, so make sure you have this memorized for the exam. Example, it says find the range of each data set. Which set has higher variation or which set is more stretched? Okay, remember that range is measuring the spread of data. Okay, so the higher the range, the more spread out the data is, or the more stretched our data is. Okay, so the first one is 1, 2, 4, 4, 6, 14. Remember, the range is just the maximum minus the minimum, so 14 minus 1 is 13. Okay, of the second data set, we have the range is the maximum minus the minimum. 7 minus 1 is 6. Okay, so this 13 is higher variation, okay, or more stretched out. Okay, this first data set has less numbers, but it's higher variation. It goes from 1 to 14, where this one only goes from 1 to 7. So this one, the second one, is more clustered together. Okay, and then the next measure of spread, this is the last one we're going to look at, is standard deviation. Okay, for standard deviation, we're not actually going to compute any. You won't have to do that on the SAT, but you do need to know what it means. Okay, so definition, it says the standard deviation of a set is a measure of dispersion of values about the mean. Okay, so what that means is we're measuring how spread out data is around the mean. Okay, meaning to find the standard deviation, we have to find the mean first, and then we're going to take all of those values and we're going to compare it to the mean and see how stretched it is. Okay, this is the formula for standard deviation. So you have the square root of the summation of x minus x bar, which that's the mean, squared divided by n minus 1. Okay, you don't need to know this, you just need to know what standard deviation is. Okay, so it measures how spread out your data values are around the mean. Okay, so example, it says 2 5th grade classes have identical mean scores on an aptitude test. Okay, so these 2 classes took an aptitude test. It came back that their mean score was the same. But one class has a standard deviation 3 times that of the other. All other factors being equal, which class is easier to teach and why? Okay, so we have two classes here. They take an aptitude test. They both have the same mean, okay, but one has high standard deviation compared to the other standard deviation, which is way lower. Which class is going to be easier to teach and why? Okay, the lower standard deviation would be easier. Put would be. Because the aptitude tests are less spread out. Okay, so the lower standard deviation, which just needs to be a D, the lower standard deviation is going to be easier to teach because the aptitude tests have less spread. So remember, the standard deviation is a measure of spread here. Okay, so that means that the standard deviation is going to be pretty close to the mean. Okay, meaning that all of these students are going to be about the same aptitude. So they're going to be around the mean. Okay, bottom of page 12, we have definition. The normal distribution is bell-shaped and symmetric about a vertical line through its center. Okay, so the normal distribution always looks like this. Okay, it says, for example, the heights of adult men are normally distributed. If it were possible to measure the heights of all adult males or the entire population, the histogram would approach the above picture. Okay, histogram is just a picture of the frequency. So I'm going to go ahead and explain the normal distribution with this information, which this page does not, this reference here does not work. So go ahead and mark that off. Okay, so we're going to put, let's just explain this first and then we'll look at this and put actual values in. Okay, so this is going to be a picture of how we said adult men are distributed. Okay, so some value here is going to be the highest number of men. Okay, and then this value here would be a lower number of men. So this is a particular number here. So this represents a number. Okay, as we move out this way, there's less and less and less and less men. Okay, as we move out this way, there's less and less and less men. Okay. Okay, it says the mean, median, mode of a normal distribution are all equal and located at the center of the distribution. Okay, so if you're given that a data value or data set is a normal distribution, you can automatically say the mean, median, mode are all here, this value. Okay, for the above picture, label where the mean, median, mode is. Okay, so this would be the very center. Okay, it says the mean height for men is now 5 feet 10 inches. So let's go ahead and write that out. So I'm just going to put 5 feet 10 inches. Okay, that's the mean. Okay, that means the average height of men is 5 feet 10 inches, and the black vertical line indicates that height. Okay, that means that most of these men, remember the mode is also here, okay, the most of these men occur at 5 feet 10 inches. Okay, so we have some value here, which we're measuring all adult men, so this would be in the millions. Okay, millions of men are 5 feet 10 inches. Okay, and this is, we could not actually measure all adult men, but this is the picture if we could. Okay, it says as we move left, less men are shorter. As we move right, less men are taller. Okay, so let's just move to the left. So maybe, and I'm making these numbers up, maybe this value here represents 5 feet 6 inches. Okay, so less men are 5 feet 6 inches. Okay, maybe this value here, and again I'm making this up, just represents 5 feet. So this would be very few men are just 5 feet. Okay, moving to the right, again I'm making this value up. If this value here was, it'd have to be in 6 feet now. 6 feet 2 inches. Okay, you see that less men, since you have a shorter height here, are 6 feet 2 inches. If we move out even more, so again I'm making this value up, if this was 6 feet 8 inches, you see even less men are that tall. Okay, so this is how the normal distribution works. The average represents the most. Okay, as we move to the right, we have less and less. As we move to the left, we have less and less. Okay, bottom of page 13, it says the shape of the normal distribution depends on the mean and standard deviation. As the standard deviation increases, the distribution becomes more dispersed or spread out. Okay, so remember, higher standard deviation means more spread. Okay, but if it's normal, it still retains the symmetric bell shape. Okay, so for example, we're moving on to page 14. Okay, here are 3 pictures of normal distributions. Okay, so you have the shorter one here. Okay, you have the middle one, and then this tall one here. Okay, this has standard deviation of 1, 2, and 3. Okay, so it says for the above image, what is the mean of the distributions? Okay, remember the mean falls directly in the center. Okay, it's also the highest values of each of these. Okay, so it would be the value here, here, and here, which represents 15. Okay, what is the median of the distributions? Remember, the mean, median, mode, and mid-range are all in the middle, so the median would also be 15. Okay, number 3, which distribution is the most spread out? Okay, or most dispersed, or the most spread out? Okay, this is going to be the one with the highest standard deviation. Okay, so this is going to be standard deviation of 3. Okay, which in the picture, okay, you can see that represents this picture here. Okay, so I'm going to go ahead and label this as standard deviation 3, just in case you can't see the color difference in these pictures. Okay, and you guys can see that this data is more spread out. This data almost reaches, it looks like, to 7 and 23, something like that. It almost reaches to that, where you still have values. Okay, this taller one, it only looks like it goes to like 12 and 18. Okay, so you can see that this third one here is more spread out. Number 4, which distribution has the highest standard deviation? Again, that's simple. That's the highest standard deviation, which is standard deviation 3. Okay, number 5, which distribution is the least dispersed? Okay, that's going to be the standard deviation of 1, which I'm going to label this as standard deviation of 1. Okay, so you can look, this first one here, this highest one, okay, has less data. It's less spread. And then number 6, which distribution has lowest standard deviation? Okay, again, that is the lowest standard deviation, or standard deviation of 1. Okay, so you will see a couple problems on the SAT of normal distributions. Things to remember: mean, median, mode, mid-range are all in the middle. Okay, the higher the standard deviation, the more spread you're going to have. Okay, so you'll have more spread out picture. If we had a standard deviation of 4, it would be even more spread out. Okay, so something like that. Okay, bottom of page 14, we're just going to touch a little bit on other kinds of distributions. It says, although the normal distribution is the most important of all distributions, not all data can be approximated by the symmetric distribution with its mean, median, and mode all having the same value. Okay, so this doesn't always happen, mean, median, and mode all having the same value. Okay, if that's the case, a distribution is skewed if a large number of data items are piled up on one end or the other with a tail at the opposite end. Okay, so for example, this is top of page 15. These are different types of distributions. You can see that they're not symmetric. Okay, so if you would fold it in half, this higher point would be over here. It's also not bell-shaped. Okay, so we have left skewed. Okay, that means you have piled up on the right and you have a tail on the left. Okay, so most of your data is going to occur over here. Okay, here mode, that's going to be the highest number. Okay, that's going to be this highest point here. So whatever this is would be the mode. The median is going to be in between the mean and the mode. Okay, and then the mean is right in the middle. Okay, again over here you have most of your data piled up on the left. You have a tail on the right, so it's called right skewed. The mode is the highest point, mean is the middle point, and then median is in between those two. Okay, so this might happen on the SAT. If it does, just make sure you understand that the mode is going to be the highest point, the mean is going to be in the middle. It is not a normal distribution. Okay, so we're going to stop there. That actually ends statistics. When we start part 4 of this section of the text, we will start with probability. We'll be able to finish, and then we'll be done with this.